We are live and we are continuing solving neetcode. So let's go of the elements matrix inside the rectangle defined by its upper left corner and lower right corner. Implement new matrix class. So we have to implement our matrix class where we receive our matrix as an input, and we should return the sum of some regions from left corner to the right corner. So let's think what we have, and let's first understand the problem. So we are receiving some matrix, and our task is to return an integer to like it would be sum of the region, right? So let's imagine we have some matrix and values. What values can be? Yeah, so it can be negative values as well, but let's for simplicity take some values like this. And we have requests. So for example, we have requests from row to the, like from row 0, 0, 0 to 1, 1, right? So we have this part like 1, 3 and 0, 1. And result in this case should be, so let's take it as request, and the result would be 5, correct? And so on. So we receive multiple such requests, and we should return the sum of our result. So what I can see here, and we have to design an algorithm with some region, and this some region should work with constant time complexity. What does it mean? It means we should not iterate and calculate the sum. We should do it somehow more efficient. And to do it more efficient, we can think about maybe about some prefix sum. So let's imagine that we have some prefix sum. So here like 1, 4, 5, right? And here like from top we have 1, 4, and then here we have like add of this 2. So 4 plus I believe 1, 5. Then we have add of this 2, so it's like 5 plus 5, 10. And let's check this. So we have here 5. 5, like 4 and 1. Then we have another 5, so 3 and 2. But we have 1, so it should be 11. So it's not correct. So 1, 3, 4. Here we should get 1. Here we should get 4 plus 1, 5, right? 5. 4, 5, and then 5, 5, and yeah, and we add the current value as well, so it would be 12. Is it correct or not? So let's check. It should be 11. Yeah, it should be 11. Should be 11. So when it's 0, here we have 4, have 1. So, and it should be like the maximum, right? The maximum plus 1 should be 5. So yeah, so it's actually not correct. So how can we do this? So first we iterate over row, and we add like 1 plus 3, 4, 4 plus 5, 4, and then 4 plus 4, it should be 8, right? Correct. And then we have 1, and 4 here. So we should take, I think, here 5, then 5 plus 8, it was 13 plus 12, it would be 15. So yeah, so it's not correct, I think. So we can maybe iterate here. So we have 0, then we have 4. So we can, for example, take the maximum, plus 1, 5, then 5 and 8, we take a maximum 8, for example, plus 2, 10. But 10 is not correct, right? So what we can do, 0, 1, 3, and 3 plus 8. Okay. 1 plus 4 plus 3. 4, 1. So we can put this here. 1, then 1 plus 4. Yeah, and minus probably diagonal, so it should be 4 like plus 6, and it should be 5. And here it should be 5 plus 8. Yes, 5 plus 8 minus 4 plus 2. And result, here it should be 4. Yeah, so result would be 11. Okay, and 5 is actually 4 plus 1 plus 1 minus 1. The result is 5. Here we just iterate and count 1, and here it's 4. Then for each operation inside, we actually do these calculations, and then when we receive, for example, give me some of, for example, here. So let's iterate and count all values in our matrix. So we need to count 2 more. So here we have 5 plus 4 plus 4 minus 1. So here we have what, 8 and 5. So it was 13 minus, so we have 12. And then here we have 12 plus 8 plus 1 minus 5. And here we have 21 minus 5. So yeah, 16. So the sum of here, it should be all 16. So let's just calculate. So here it's 10. Yeah, but we see that it's more than 16, right? So yeah, so we have 4 plus this 2, it's 10. Then we have 15 plus 1, it would be 16. And plus 3, it would be 19. So we have 19. So we calculate something wrong. Okay, so here we have 5, it's correct. Then here we have, how much? We should have 11, right? We should have 11. We should have 11. Is it correct? So 5, yeah, plus this 5, so it should be 11. And if we go this way, so we calculate, for example, the top, it's 1, 4, 8, and then here we have 1. Then here we calculate 4 plus 1 plus the current 1, 6 minus 1 is 5. And then we have the following. We have 8 plus 5 plus 2 minus 4 equal. So here we're left with 4. And yeah, so equal to 11. So here it should be 11. Then we have 1, so it should be 4. Then here, if we take this part, we have 4 plus 5 plus 4 minus 1. So in this case, it should be 5 minus 1 should be like plus 3. So it should be like 12, I believe, right? Yeah, so we had 5 plus 2, yeah, so it would be 12. And if we calculate, so we have 3 plus 3, 6, 7, 8, 12, so it's correct. And then at the end, we should do the following. We should do 12 plus 11 plus 1 minus 5. And if we calculate all this thing, we have 24 minus 5 would be 19. Yeah, so looks like this correct logic. And what if someone will ask me calculate from this one to this one? So I have 5 and 19. So 19, it's like the top, all these elements. And 5, it's all these elements. And 19, it's all these elements. So to calculate from 5 to 19, I should actually eliminate this top and the first column. So to eliminate first column, it's actually this 8, right? So I need to decrease 19 from 8. To eliminate this column, I should take 4. So in total, I should eliminate by 12. By this 12. And then I should get. Because if I will eliminate this one, then it actually looks not correct. It looks not correct. So what then should be the logic here? Let's think. What should be the logic here? So actually, if I will take this 5, it means I take this one. 19, if I like reduce 19 minus 5, it would be 14. And 14 is definitely not correct value. So because it should be 8. But if I will take this 8 and this 4, so it's actually diagonals, right? So I take this value from here and I remove diagonals from this 5. And if I want the total sum, so if I want the total sum, so I don't have any diagonals. If I want, for example, this first, this one, so I receive like 4 and I receive 19 and I want all this one. So my goal is to remove this 4, but this 4 is not on the diagonal, correct? Correct. And so this one is by diagonal. And if I receive this one and this one, like here, right, I can receive this one. So I have only two. So I should remove like this and this. And also, for example, if I want to calculate only the bottom, then I need to remove this part. Yeah, so it's actually the question here, how to understand which parts I should remove. So it looks not really obvious to do this, and how to find out this. It's not really obvious. Interesting. So what I can do another way. So for example, I can calculate prefix sum. Maybe also I can calculate suffix sum. So for example, I can start from bottom, and I can calculate suffix sum. So here at the bottom it would be 1, then I go up 3, then I go up 9, then I go from here, it should be 5, then I go from here, it should be 3, then I go for here, it should be 9 minus 1 should be 8. And now, yeah, so when I have these two prefix and suffix, I can just remove this one from this one. Why? Because here I have the total sum of my metrics, and here I have only values that I need. So this one is actually the sum of this bottom line, right? So it's like 4 plus 4, it should be 8. But if I remove, it's actually all others. So all others should be 11. So if I will calculate them, I have 3, 4. So here's 9 plus 5. Yeah, it's 14. 14. Okay, then here what I have. Here I have 0, so it's actually 11. Yep. It should be 11 minus 5, 6. But is it correct? Because it should be 8 plus 3, 11. But 5 minus 5, 5, 11. So it should be 11. Here we should have 11. And here 3 plus 5 8 plus 1, say minus 1. Here we have 8 plus 5. Yes, here should be not 3. It should be 5, 6, 8. So we have 16 minus 5. Yeah, we have 11. So now it's correct. Here we have 9. Yeah, but still, for example, we have 8 and we have an 18, right? So we cannot calculate the sum that's here. We cannot calculate the sum. Like we can take prefix. If, for example, we want to calculate this one. And here I have 3. Yeah, so I have 11. So it should be 10, right? And in this case, I have 9 plus, it will be 17 plus 3, 20. And it will be 17. And then the last one, 28, 29, 21. Wait. 17 plus 11, 28, right? 29, 21. How is possible? How it's possible? So this 17 is actually the sum of these 4 elements. It's 8, 10, 12. So it should be 15. So how I calculate this? Should be 15. Yeah, because 17 minus 3 is actually 17 plus 3, 20. And 20 minus 3, 17. Yeah, so I think it should be, yeah, something different is going on here. So let's check solutions, because I think that I'm a little bit lost here. So now the solution, summarize each region to n squared. Yeah, so here it's pretty common one. Okay, complexity. Yeah, understand. Yeah, so it's Naven, so we don't need this. We need something else. Construction 2D array. Okay, so pretty much I think closure, DP visualized, interviewed step. How do we come up with this? Okay, so logic. If you're a bit unclear on how the dynamic programming relationships here, hopefully the below diagram clear it up. Okay, this area is abstracted. Okay. So we have this and this subtracted. Okay, so it's calculated multiple times. So we need to subtract this area. Okay, makes sense. So if, for example, we have a prefix sum, and this one is this total area, and we want to subtract from total area this area, right? And so we have this 5, right? So from 19 we subtract 5. So definitely, like, we subtract this area. but we don't want to subtract 5, right? So we want to subtract this one and this one. Still, I cannot understand this. Okay, I think we need some help. I think we need some help here. And yeah, so after I will actually check how it works, then I will record a video with explanation. So for now, that's it. Thank you.